Find the probability that a randomly selected adult has an IQ that is less than 115, assuming that IQ scores have a mean of 100 and a standard deviation of 15, and are normally distributed. Then we'll find P30, which is the IQ score separating the bottom 30% from the top 70%. This goes back to the discussion about percentiles that we had in the previous chapters. So let's answer the first question. We're going to find the probability that a randomly selected adult has an IQ score that is less than 115. So to do that, the first thing we need to do is convert 115 into a z-score so that we can look this up on our standard normal distribution table. So we'll use our formula for the z-score and take 115 minus the mean, which is 100, and then divide that by our standard deviation. Of course, this comes out to be 15 over 15, so I know the z-score is 1. So now we'll look up the z-score of 1 on our table. Of course, what the table is going to give us is the probability that So I need to find the z-score 1 on my table, and that is 1.00. That tells me, looks like it's going to be 0.8413. So this tells me the probability that an IQ score, randomly selected IQ score, would be less than 115 is about 84%, or 0.8413. So now let's find P30, the IQ score that separates the bottom 30% from the top 70%. This is the same thing as thinking about the z-score that on our normal distribution would have 30% here to the left of it. So we need to find this z-score that has 30% to the left of it. So that'll take us to the table, and we can find where 0.3 is, which represents 30%. That'll give us a z-score, and then we have to convert that into an IQ score. Let's look at the table. So on my table, I need to find 0.3, which is 30%. So let me scroll down. Let's see, I see 0.33. And we're going down as we go to the left, and I get to 0.3015 and 0.2981. So the question is, which one is it? Well, if you think about how far away each of these are from 0.3, I would have to add 0.0019 to this one. And here, I'm only 0.0015 more than 0.13. So in other words, 0.3015 is closer to 0.30, so that's the one I'm going to choose. Now that means I have to find the z-score associated with that. So of course, if I look to the right, I see I'm in the negative 0.5 row, and then I know that the first column is 0.00, the second column is 0.01, and the third column is 0.02, so that means 0.3015, the z-score associated with it is negative 0.52. So if we found our z-score to be negative 0.52, we need to take that z-score, that was a negative, we need to take that z-score and convert it into an IQ score. The way we're going to do that is use essentially the opposite of the z-score formula. That is, if we're converting to some x value, we're going to take our z-score, multiply times the standard deviation, and then add the mean. So in this case, we said our z-score was negative 0.52. Our standard deviation is 15, and our mean is 100. So plugging all this into the calculator gives 92.2. That is, the z-score 92.2 has about 30%, or I should say it this way, 30% of IQ scores fall below 92.2.